Okay. So limits, what's the first thing that you should do with any limit? Nope, it doesn't. You're trying.
What are you doing?
It doesn't matter. If I'm trying to find the limit of a function, and it tells me the limit in case number one, as x approaches 2, what's the first thing? I plug in x equals 2 into that function. Alright, so number one thing, plug x into, or plug x value into limit. Right? If you get a number, then you're done. Okay? If you get undefined meaning undefined means 0 divided by 0, something divided by 0, something bad that you can't do. Undefined, you got more work. You got more work than undefined. Okay? Questions about this? Alright. So, we'll look at number one. Okay. Number one says the limit. Quiz. X approaches 2 of x squared plus x minus 6 divided by x squared minus 4. Yes.
We got that one right.
You all got it right? Okay, first of all, here's what we do. The first step is to plug 2 in. Okay? So, you know, that's what you do.
Mom?
Yeah.
Oh, this is not your handwriting.
So,
Wait, is ours mom or something?
yeah, that's right. I know there's something going on. Yeah, that's not right. So you actually have more story. So, what we do here is first plug in 2. If I plug in 2 here, I'm going to get 4 plus 2 is 6, minus 6, that's 0. 2 squared minus 4 is 0. So I'm going to get 0 divided by 0, which is undefined. Alright? So, the first thing that I need to do then is, I see a quadratic over a quadratic. To me, that's telling me I need to go ahead and factor stuff. Okay? Now, what I'm going to do here is I'm going to say the limit as x approaches 2. Okay? So that's going to be, now I know that I have to plug in that 2. I know that 2 is making the denominator 0. Okay? So I know pretty much that this denominator is going to have x minus 2 in it. Okay? Because I have to factor this quadratic. So I'm going to get the x minus 2 times x plus 2. Okay? This numerator, actually no, it is. This right here is going to be x plus 3 times x minus 2. And the x minus 2 is cancel out.
Okay, why do you have a random x?
I don't have a random x.
Attention coaches and advisors, at this time, please make sure you have all of your students and they are accounted for. Again, we've had too many students unsupervised in the building after school. Students, if you're still in the building and you're not here for after school activity, you have 2 minutes to exit the building or you will be escorted out. So coaches, please, advisors of any program, band, etc., please make sure all your students are accounted for, and we will be doing a sweep of the building to remove any students who are not here for protective reasons. Thank you.
5, 4.
What we had.
I see you, know. Want to see if you guys are ready.
I really got to check, making I was right, and we did go over this one in class.
Okay. Questions about that one?
No.
Okay. Number 2. Says the limit of x approaching 0 of x squared plus x plus sine of 2x divided by 2x. Okay, if I plug in 0 here, what's going to happen? See, 0 and 5 give me 0 over 0. Yes, I get undefined. Right? Now, I see this. Okay, I see the numerator and broke it up. I also see that there's a sine of 2x and a 2x here. Alright? So right there, that's telling me, man, if I can break this up and just get sine of 2x divided by 2x, I'm good to go with that part. Alright? So what you need to remember is that with limits, just like derivatives, if there's plus signs up here, you can start breaking this apart. Alright, so what this is equal to is the limit as x approaches 0 of x squared divided by 2x plus x divided by 2x plus sine 2x divided by 2x. Because this is all, if I combine all this, the common denominator just stays 2x, and that means I can just add all that stuff in the numerators. So, let's rewrite some of this stuff. This x cancels out with one of these x's. This x cancels out with this x. This is cool because I have that memorized. 1. Alright, so what I now have is this. Alright, so now I have that this is equal to the limit as x approaches 0 of x over 2 plus 1 over 2 plus sine 2x divided by 2x. So the limit as x approaches 0 for this, x over 2 would just be 0. The limit as x approaches 0 for 1/2 is just 1/2. And the limit of sine of 2x over 2x for as x approaches 0 is equal to 1. So I am given 1/2 plus 1, which is 1.5 or 3/2. Question about that?
So 1.5,
Yes, or you can write it as 3/2. Right? Question?
No.
No. 3. Okay. This one says the limit as x approaches 0 of x divided by x plus 1 minus 4 divided by x minus 1. What's the first thing that we should always do? Plug 0. So if I plug 0 in, I'm going to get 0 over 0 plus 1 minus 4 divided by 0 minus 1. Well, 0 divided by 1 here, that's just 0, minus 4 divided by -1, that's -4,
So 0 minus negative 4 is equal to 4, so that is 4. That is why you can plug stuff in at all times. All right. Next. Number 4. What you got out? Nope. Number 4 says a limit as x approaches 0 of the sine of 5x over 3x. Now, the number one, first of all, we sure to do it tell us like, okay, so clearly in this one, I'm going to probably want to find a way here to use my little trick where I have like, if I have the limit as x approaches 0 of sine of something over that same something, it equals 1. So like, that said 5x instead of 3x, and you say sine of 5x over 5x, yeah, in that case it'd be 1. If you have that number. So 2 things. One, I want you guys to know how to do this mathematically. 2, okay, is, here's the shortcut. The limit of this is just whatever is in front of this x, whatever is in front of this x, and you just do 5 divided by 2. So the limit of this is 5 thirds. Okay. The limit of that is 5 thirds. So, how do we do that mathematically? Well, first of all, I know that this right here, if I can get this to say sine of 5x divided by 5x, I can use my little trick. Alright? So what I'm going to do is I'm going to multiply this by 5 over 5. Okay? So what I do is I take this and I'm going to go sine of 5x divided by 3x. I'm going to multiply this by 5 over 5. Okay, so what that does is that allows me to say, okay, so this is going to be 5 sine of 5x divided by 3 times 5x. All I did is I rearranged the order of the multiplication there. I'll do that. So I have, this really is equal to 5 thirds times sine of 5x divided by 5x. So 5 plus sine of 5x divided by 5x. What's the limit of that? Is x approaches 0? 1. 5 thirds times 1 is equal to 5 thirds. On my quiz, I'd like to see some work. On the AP test, that'd be a multiple choice question. So if you just remember that it's 5 over 3, then that's all you have to do. Questions so far? All right. All right. So, 5. So, number 5, there's a limit as x approaches infinity. Sine of 5x divided by 2x. Alright, so when x approaches infinity, okay, just automatically assume, okay, first of all, you can't plug in because x approaches infinity. You can't plug in. When x approaches infinity, you're looking at what is my horizontal asymptote. Remember, if the degree in the numerator is larger than the degree in the denominator, there's no horizontal asymptote, so you're going to be having to think about something else. If the degree in the numerator is less than the degree in the denominator, your horizontal asymptote is y equals 0, therefore your limit is 0. If the degrees are equal, it is the leading coefficients of the numerator and denominator, and then you just divide them. So in this case, the highest degree in the numerator is 0, because it's sine of 5, that 5x doesn't count. And the highest degree in the denominator is 0. So the degree in the top is 0, degree in the bottom, 1. The degree in the denominator is 1. So since the degree in the numerator is less than the degree in the denominator, that tells us that our horizontal asymptote is at y equals 0, which tells us that our limit is at 0. Okay? Questions on that one? Okay. We will look at number 6 now. Okay. Number 6 says the limit as x approaches 0 of sine of 5x over 3x. Says sine of 4x divided by cosine 5x. Okay. What's the first thing we always do when we're checking limits? Plug in 0. If I plug in 0, I'm going to get sine of 0, because it's 4 times 0, divided by cosine of 0. That's equal to 0 divided by 1, which is equal to 0. That's why we plug something. Okay. Questions so far? Okay. Any other questions? Seven says the limit as x approaches 0 of 4x squared plus 3x sine x over x squared. Okay. First thing I'm going to do is plug in 0. That's going to give me a 0 in the denominator, so that's bad news. The next thing I'm going to do is I'm going to look up in the numerator and see that they're being added. So I should be able to do what here? Break it apart. So it's going to be equal to the limit as x approaches 0 of 4x squared over x squared plus 3x sine x divided by x squared. Okay? Now, what we have here is we have a couple x squared canceled out right here. Okay? This x, so I cancel out with one of those x's. So what I'm left with is 4 plus 3 sine x divided by x. Okay? So what I can do here is I have the limit as x approaches 0 to 4, that's just going to be 4, so that's 4 plus, now, if you need me to, I can show you one set y, but remember, we can break up this 3, so that's 3 and sine x, so this 3 all we're doing is multiplying sine x divided by x by 3, so what's the limit as x approaches 0, sine x divided by x? 1 times 3 is 3, so the total of 2 is 7. Okay. Number 8. 8 says the limit as x approaches plus or minus infinity, x cubed plus x squared divided by 2x to the 4th plus 6. Okay, so it's approaching positive or negative infinity. Therefore, we aren't plugging anything in. So we're going to be looking at what? Horizontal asymptotes, which we do by finding the degrees of the numerator and denominator. The degree of the numerator is what? Less than the denominator, because 3 is less than 4. Therefore, that tells us that the horizontal asymptote is that y equals 0, therefore my limit is 0. Alright. So look at 9 now. 9 says the limit as x approaches negative 4 on the left. Negative 1 divided by x plus 4 plus 3. That's asking about the left side of the limit. So what I would do here is I would have to just say, okay, I'm going to take negative 3, I'm going to take negative 4.001. Alright, and I'm going to plug that in. Negative 1 divided by negative 1 divided by negative 4.00. Yeah, you don't even care about 3. Alright? I don't care about 3. Okay? So what we do is it's a constant and it's not effective. It has nothing to do with effect. Think of it this way. If I'm adding 3 to the y value in the long scheme of things, that's not going to really affect. Alright? So I have this equals to negative 1 divided by negative 0.001. Whenever I divide a number by something really, really small, it's going to get really, really big. So negative divided by negative is positive. So it'll be positive infinity. Okay? Questions about that? If we look at number 10. It says given h of x equal to 2 cosine x 0 and x is equal to 0. 1 minus x squared, x is greater than 0. Okay. It says find the limit as h approaches 0 of h of x. Okay, so in order for the limit to exist, what must be true about the left and right hand limits? So they must be equal. Alright? So that you're thinking that's for the horizontal tangents. So it needs to be true here in the limit on the left hand side and the limit on the right hand side need to be equal in order for this limit to exist. So I would look at the limit on the left hand side. So if the limit as h approaches 0 on the left of h of x. Okay, so approaching from the left is going to be 2 cosine x. So if I plug in 0, so h of x in this case will be 2 cosine x. Okay, so so if I plug 0 in there, it's going to be 2 times cosine 0. Cosine 0 is 1. 2 times 1 is 2. Okay? Then I have to check the limit as h approaches 0 to the right of h of x. In this case, it's 1 minus x squared. 1 minus x squared. If I plug 0 in here, I'm going to get 1 minus 0, which is just 1. Is my left-hand limit and my right-hand limit equal? Therefore, this does not exist. Questions about that? Yep. Number 11 says if you have this function f of x is equal to 3x cubed minus 4x plus 1 divided by 2x minus 5. Alright. It says find the end behavior model and use it to evaluate each limit. So end behavior model we talked about briefly. All that is find the highest and lowest, the highest degrees in both the numerator and denominator. In this case it's 3x cubed divided by 2x. Okay, well that's equal to x, 1x cancels out, so this x cancels out with one of these. So I'm left with 3x squared over 2. So that's my end behavior model. Okay. Now all then it uses that to ask me what is the limit as x approaches infinity of f of x, and the limit as x approaches negative infinity of f of x. Okay? Here's what you need to know. Okay? So all you have to do is think to yourself, if I plug a really big number in here, so let's say 10,000. 10,000 squared is going to be a huge number, right? So I'm going to multiply that by 3 and divide by 2. That's going to be still a really big number. So this function is going to approach positive infinity. If I take a really small negative number, so like negative 10,000. Negative 10,000 squared is going to be another positive number. So it's going to be the same thing as this one. So it's positive infinity. The other way that you can tell is this is a quadratic end behavior model. We know that positive 3x squared divided by 2, the graph will look something like this. Right? So as you can see, the limits approach positive infinity on both the left and right hand side. Question? Oh. Wait. Alright, so number 12, that's, you have this function f of x is equal to x squared plus 6x minus 7 divided by x minus 1. It says, where is f of x discontinuous? Okay, well, first of all, I know it's going to be discontinuous at x equals 1. Is that? So I'm going to factor this. Okay? So, x minus 1 cancel out. I'm left with x plus 7. Okay? Alright. Well, so first of all, what I know is that it says, where is discontinuous? Well, it's discontinuous at x equals 1. Okay? So what I need to do now is I need to write this extended function. So in order to find the extended function, I need to figure out what is that, what y value is that function approaching. So essentially, I'm just finding the limit as x approaches 1 of what I'm left with, x plus 7. Well, I just plug that in, that equals 8. So what I get is f of x is equal to my extended function would be x squared plus 6x minus 7 divided by x minus 1 when x is equal to 1, and be equal to 8 when x is equal to, when x is, well, sx not equal to 1, x equal to 1. Alright? So, the next part is your calculator part. Okay, again, this one, find this time, and then you just find the limit of whatever's left over. As x approaches whatever x equals 1 in this case, and then you write your extended function. Okay? So, now, let's look at this next problem. So the next problem says, estimate each limit accurate to 3 decimal places using graphs or tables. Okay, in this case, now you use calculator. Okay, so we have, I'm going to graph this, says 2x cubed and 13x squared plus 19x plus 4 divided by 4 minus x. Alright? Now I'm just going to look at the table. Okay? So actually, I'll hit graph this. Okay, so here's what my graph is going to look like. Alright? Now, so at this point, what you're going to do is you're just going to look at the table. So you hit second window. Alright, my table start says the limit as x approaches 4. So my table start would be 4. Okay? My table jumps, I want to be 0.001. Okay? So I'm going to hit second graph on the table. If I look here, I can see that this is approaching what y value? Negative 11. There's my answer.
Is this recorded?
Yes. Questions about that? Again, so now the second question says y equals the absolute value. So you go math. Actually, first of all, put this in parentheses. So math, we're going to go to the number, absolute value, so it's the first one, to x, plus sign absolute value sign, plus 3 parentheses, divided by x minus 1. Alright, I'm going to graph that just for fun. This is what the graph looks like. And what I'm going to do is I'm going to go ahead and say second table set. And I'm going to pick, so it says as x approaches negative infinity. So I'm going to choose like, let's say negative 5,000. Okay, and I'm going to go to the second table with that y value. Negative 2, there's your answer. Pretty simple, huh? Now, number 15 says you can use the calculator. All right. However, okay, let's just see how easy this is without even using a calculator. Okay. So it says f of x is equal to x cubed plus 2x squared minus x plus 7 divided by x cubed plus 7x squared minus 5x minus 75. First thing it says in part A is, what is the limit as x approaches negative infinity of f of x? So if we're looking at a limit where x approaches negative infinity, okay, we're looking at what? The end behavior is going to be the same as what? Well, look at that because it's going to be the same as what? Horizontal axis. So if we look at the exponents, the highest degree and lowest degree, or the highest degree and the numerator and denominator are equal. That means that I'm going to divide the leading coefficients to get my horizontal axis. 1 divided by 1 is equal to 1. Therefore, this limit is equal to 1. That's cool. Part B is, instead of negative infinity, it says positive infinity. It's the same thing, because it's the same as the horizontal axis, right? Okay. C just asks what is the limit as x approaches 0. Okay, well, first thing I'm going to do is I'm going to see if I can plug 0 in this really quick. If I plug 0 in the numerator, all of this cancels out, and I'm left with 7. If I plug 0 into the denominator, all of this cancels out, and I'm left with negative 75. My answer is equal to negative 776. I know, that was really easy, wasn't it? Now, part D, it says I can use my calculator, so I'm going to take advantage of that. I'm going to type this in parentheses. X to the third plus 2x squared minus x plus 7 divided by parentheses. X to the third plus 7x squared minus 5x minus 75. Parentheses. Graph. So this says, so there's my graph, it's a little crazy. It says, as x approaches negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. And it says, as it approaches from the, I believe that is a left. So as it approaches from the left, what y value is going up to? There you go. Positive infinity. That's part B. Part E. Okay? It says the limit as x approaches 3 of f of x. So here's my question. Look at the graph. Okay? What must be true in order for the limit to exist? The limit on the left must equal the limit on the right. So x equals 3. 1, 2, 3. Well, first of all, it looks like it breaks apart right here, doesn't it? So the limits right here, this goes to negative infinity, so the positive infinity. Are the limits equal? No. Therefore, this function does not exist. That limit does not exist. Okay? Now, it says state all horizontal and vertical asymptotes. Okay? Vertical asymptotes are going to be right here at -5 and +3. Horizontal asymptotes, you already know what that is, right?
I got -6.
Should be -5. Is -5.
Are you sure?
-5 is this. Second trace, find the value at -6. Is equal to number. So you got it here.
That's a value of 0.
You brought the value. So if you type in -5, it's 25. Alright? The horizontal asymptote we already found the y value of, which is 1, because of the degrees in the leading coefficients. Questions about that? Okay, one last one, number 16. Which you got right?
I think I got it right too.
Oh, okay.
I
Didn't care about you. Alright. Let's look at 16. It says find the value for a so that the function f of x equals, so we have f of x is equal to 2x plus 3, and x is less than or equal to 2, and ax plus 1, and x is greater than 2, so that it's continuous. Now, in order for something to be continuous, remember we need, first of all, the function values must be equal. So what we know is 2x plus 3 must equal ax plus 1. Alright? And we also know that in order for it to be continuous, the function values must be equal and it must be the left hand limit and right hand limit must be equal. Okay? Well, and if the function values are equal, then the limit's going to be equal. So so x is equal to 2. So we're going to have 2 times 2 plus 3 equals a times 2 plus 1. So 2 times 2 is 4 plus 3 is 7. It's equal to 2a plus 1. I'm going to subtract 1 from both sides. I get 2a is equal to 6. Divide by 2, I get a is equal to 3.
Yes, I got that.
Alright? That's good.
Oh, Jesus Lord, I'm very
When are you guys taking this again? Huh? I know it's a 400.
Before this Monday coming up?
Yep, need to do better this week. Move your line. Look at glucose to be exactly like this.
Okay.
Except different columns.
Alright, well, whenever you free, you know, keep it the accent.
First period Monday and Friday, second period Tuesday and Thursday, and or Tuesday and Friday. Second period Tuesday and Thursday.
I'm ready to reach, you won't let me leave.
Are we free at our lunchtime? Free at lunch?
I'm gonna take you Friday. Friday, Thursday, I'll figure it out.